The next set of examples that I would like to look at is with rational inequalities. So if you could turn to page 16, and I'm going to start off with problem number 5. In problem number 5, the first step of shifting everything to the left side is already done for you, and also it being completely factored is already done for you. And so in the numerator we have x minus 3, x plus 2, and then in the denominator x minus 1 is less than or equal to 0. So I could just read off my critical numbers of x equaling 3 and negative 2 when the numerator is 0. And then when the denominator is 0, which means that the function is undefined, and we know that these are vertical asymptotes, is when x is equal to 1. So I have a total of 3 critical numbers. So they are x equals negative 2, 1, and 3. So I draw out my number line and I put it in order. So it's a negative 2, 1, and 3. And then I'm going to test out my numbers. So I put in a number to the left of negative 2 in this interval, so say negative 3. And if I put it back in here, I have to consider 3 different factors here. So I have a negative here, a negative, and a negative. So overall, this region will be a negative. Between a negative 2 and 1, I'll be putting in 0. So that will be a negative, positive, and a negative. So overall, that will give me a positive. Between 1 to 3, if I put in a sample number of, say, 2, then overall I get a negative. And then to the right of 3, it's all positive, so I will get a positive. So since I have the inequality of less than, then I'll be taking all of my negative regions as my answer. So it'll be this region from negative infinity to negative 2, and then from 1 to 3. And then I look at my, it says less than or equal to. Now this is where you have to be careful. You may be tempted to just say everything's going to be bracket, 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 bracket. However, at x equals 1, it's a vertical asymptote. So it'll be good for you to just circle 1 and just write below it as vertical asymptote, VA. So you know that you cannot include that. So it can be negative 2 because that'll make the 0 in the numerator, which is okay. And 3 is also fine because that'll make it 0 in the numerator. However, you can't have 0 in the denominator, so you have to exclude 1. So my final answer is negative infinity to negative 2, bracket, and then union. At 1, it's a parenthesis, not a bracket, comma, 3, and then a bracket. So for my graph, I put in this as my left side as y1, and then 0 as y2. So in blue, I just sketched it out, and then the red is my y2. And so the question is, where on the graph do you have y1 that is less than or equal to y2? So where is the blue below the red? So that would be in this region right here, and also in this region right here. So that verifies your answer down here. Okay, the next example I want to do is right below it, problem number 7. Okay, in problem number 7, if you could circle it and star it and then write out this comment here. Do not cross multiply. There's a great tendency to want to just cross multiply 5 times x plus 1 and 3 times x minus 3 and then solve it like you would an equation. But remember that this is an inequality, so if you cross multiply, you're going to end up losing out on all the denominators. So you have to follow the 5 steps that I wrote out on the previous page. So the first thing is you have to shift everything over to the left side. So I'm going to bring the 3 over x plus 1 to the left side. And so you'll have 5 over x minus 3 minus 3 over x plus 1. Then I need to find a common denominator. So I'll use x minus 3 and x plus 1. So then in the numerator of the first fraction, I need to have an x plus 1. And in the numerator of the second fraction, I need a x minus 3. So denominator, I'll just keep it as it is because I like it in the factored form. And then the numerator, I'll distribute 5x plus 5 minus 3x plus 9. And then combine your common terms. So that's 5x minus 3x is 2x. And then 5 plus 9 is 14. And then in the denominator, again, just keep it the same. And I'm going to factor out a 2 in the numerator, which will help me to read off my critical numbers easier. So I have 2 quantity x plus 7 over x minus 3, and x plus 1 is greater than 0. So my critical numbers are at x equals a negative 7, 3, and a negative 1. And then you'll put this on the number line, negative 7, negative 3, and negative 7, negative 1, and 3. And then do your test numbering again. So to the left of negative 7, and I'm going to put it back into this one down here. Okay, so put it into the most factored form. And so if I put in a negative 8, I'll get the 2 is always a positive, so I can just disregard that. So I'll get a negative, and a negative. So 3 negatives will give me a negative. And then in the region of negative 7 to negative 1, it'll be a positive. In the region of negative 1 to 3, it'll be a negative. And in the region of 3 to infinity will give me a positive. So I want to circle the ones that will give me 0 in the denominator. So that's negative 1 and 3, because those are the denominators there. And I know that if I were to graph it, I would get vertical asymptotes. So I look at the greater than, so I want the interval where it is positive. So that would be this interval and this interval right here. So those are my solutions. And since it says just greater than, then I'll just make everything as parentheses. Okay, now if it said greater than or equal to, then I would have a bracket here, parentheses and parentheses. But since it says just greater than, I'm just going to be using parentheses everywhere. So my final answer on this is a negative 7 to negative 1, union, and then 3 out to infinity. And you can also verify this with your calculator. Okay, I'd like you to turn off the video right now, and I want you to try problems 4, 6, and 8 on your own. And once you've completed them, you can come back and check your solution. Okay, I trust that you guys did this on your own, and now I'm going to go through the answers. So for problem number 4, it's already in, the left side has the function, and then the right side is 0. And so my critical numbers are 3 and a negative 1. So here's my number line, negative 1, 3. It's positive to the left of negative 1, and in between the interval of negative 1 and 3, it's a negative, and then to the right of 3, it's a positive. So my solution is negative infinity to negative 1, union, and then I'm going to be including 3 and not including a negative 1, and so it's bracket 3 out to a positive infinity. And I've also shown this graphically. The red graph is the rational function, and then 0 is the green function. So you want to know where is the y1 greater than or equal to y2. And so it would be in the region of negative infinity to negative 1. This would be a true statement. It's a false statement in this region, and then it's a true statement here. Okay, so next one is problem number 6. So for problem number 6, I want to shift 7 to the other side, so I get x plus 12 over x minus 7 is less than 0. Get a common denominator, and then I just rearrange it so that it's better to factor. So that'll be x squared minus 7x plus 12 divided by x is less than 0. I factor this numerator, and I get x minus 4 and x minus 3 divided by x. So my critical numbers are at 0, 3, and 4. So place this onto the number line and do my signs testing. So in this interval, it's a negative. From 0 to 3, it's a positive. From 3 to 4, it's going to be a negative, and greater than 4, it's going to be a positive. So my solution on this is from negative infinity to 0, union 3 to 4. And here's my graph to justify it. Okay, the final one is problem number 8. So in problem number 8, everything's shifted to the left side already, so I'll just factor the numerator, and I get 3x minus 1 and x plus 1 divided by x plus 2, and that's greater than or equal to 0. So my critical numbers are at negative 1, negative 2, and 1/2. I do my signs chart, and I have negative 2, negative 1, and positive a third. So this is a negative in this interval, a positive, a negative, and a positive. So my solution is negative 2. This has a parenthesis because this is a vertical asymptote, so even though it's equal to, I'm not going to include it. A negative 1, bracket, union, bracket, 1/3, out to infinity. And here is my graph. Now there's a little bit more down here, but I actually don't need it because the question is asking where is this rational function greater than or equal to 0. So I know that this region is going to get it all covered.